Okay guys, this is the Mario Algebra review game that you did in class today. I'm going to go over it just to make sure that you, for any questions that you had to kind of clarify and get you clear there. And then if you have any questions, you're more than welcome to come see me in the morning. I'll be here and I'll be able to answer any questions so that you can feel comfortable before you take the test tomorrow. Question number, so let's review our linear transformations, because this test is over linear transformations and it is over scatter plots. So let's talk about the transformations that we did talk about. So we talked about 3 different types. The first one we talked about was transformations, or translations. So we talked about translations. Remember that we said if the number was on the outside, so if you had the number on the outside, if you were adding or subtracting something on the outside, so subtracting, let's say, like 2, this was a vertical shift. Okay, if it was adding something, that was a shift up. And if you were subtracting something, that was a shift down. And then for the number being on the inside, so we have f of x plus 2, okay, a number. This was a horizontal shift. Actually, that's right there. So this was a horizontal shift. Now remember, this one's a little backwards. If it was plus on the inside, it was actually moving it to the left. And if it was minusing on the inside, it was moving it to the right. Alright, then we had reflections. So we talked about reflections. That was the next thing. So we had translations were the first thing that we talked about. Then we moved into linear reflections. Remember that if the number was on the, if the negative was on the inside, this was a reflection over the y-axis, which meant that the y-intercept stayed the same and the x-intercept changed. And if it was on the outside, this was a reflection across the over the x-axis. And this meant that the x-intercept stayed the same and the y-intercept changed. And then the last ones that we had that was dealt with slope change. And you had 4 different types. So we had horizontal compressions and stretches. And then we had vertical compressions and stretches. So vertical compressions and vertical stretches are when the number was on the outside. So our vertical changes. So vertical numbers on the outside. So that was 2 times f of x, or a fraction, such as 1/2 times f of x. Okay, if it was a number that was large, remember that it is stretching it to the closer to the y-axis, so we said that's a vertical stretch. And when it was a fraction on the outside, that was a vertical compression. Okay, and then we have horizontal. So we had horizontal slope changes. Okay, and this is when the number is on the inside, that's a t. So we had f of 2x. Notice now the number's on the inside. Or f of a fraction such as 1/2 x. Number's on the inside. This was backwards, so it's different than vertical. If the number was larger than 1 on this one, it was a compression. You're compressing it to the y-axis. Or it's a stretch. If it's a fraction and you're stretching it towards the x. So those were our 6 really different types of transformations. And so with that, once we reviewed that, let's go through and do question number 1. So question number 1 says to describe the transformations from the parent graph. Again, I would have that foldable that you made on Monday out with you so that you have that. And this says describe the transformations from the parent graph. So g of x equals 2 times f of x plus 1. That's where we're starting. Okay, we have 2 transformations that are happening. The first one that we see is the 2 times f of x. We know that that's slope change because it's multiplying by a number. The number's on the outside, so we know that that has to do with vertical And because it's a number that is larger than 1, we see that that is a vertical stretch. So we have a vertical stretch of 2. And then we also see that there's something being added on the outside. So that would be a translation. Because the number's on the outside, we know that that's vertical, and it's being shifted up by 1. So we have a vertical shift up by 1. So if we look at our answers, we can see that we have a vertical stretch of 2 and that we moved up 1. Looking at question number 2. Question number 2 says describe the transformation. So we're given our original function, which is f of x equals 2x minus 4. And then we're given g of x equals negative f of x plus 1. So again, we have two transformations that are happening. We see there's a negative that's now being added to f of x. So we know that that has to be a reflection. And when the negative's on the outside, that's a reflection across the x-axis. So when it's on the outside, we know that we have a reflection across the y-axis. No, x. So reflection across the x. Again, have your foldable out with you as you're going through these questions so that it kind of clears up any confusion. So reflection across the x-axis. Okay, and then we see again there's something being added on the outside, so that goes with the translation. Because it's on the outside, we see that that's vertical. So we have a vertical shift up by 1. Okay, so again, we check our answer, we see a reflection across the x-axis, and it moved up 1. Okay, so 7, again, describing the transformations that are happening. So, we actually have two transformations happening here. So we have our original function, which is f of x equals 2x minus 1. And then we have the transform function, which is f of negative 3x. Now, we have a negative, which is one transformation, and then we have the number 3, which is describing the next transformation. So the negative means that we're reflecting. And because the negative's on the inside, that's a reflection across the y-axis. So we have a reflection over the y. So reflect over the y-axis. And then we have the number on the inside, which means that it's horizontal. It's a number that's greater than 1, so this would be a horizontal compression. So we have a reflection over the y-axis, and we have a horizontal compression. So think about those numbers when you're where they're located, and then what type they are to figure out if it's a compression or a stretch. Okay, remember that we said stretching horizontally is pulling or pushing, okay, towards the y, and stretching vertically is pulling or pushing towards the x. Okay. Describe the transformations and then write the new equation. So for 4, it says describe the that's what we're going to do. So on 4, we see that our original function is f of x equals 1/2 x minus 1. And we have our transform function is g of 2x. So we see that, describing it, we see that we have a vertical, because it's on the outside, that we have a vertical stretch. Because we went from f of x to 2 times f of x, so we have a vertical stretch. So vertical stretch of 2. Okay, and then it says write the new equation. So remember that when the number's on the outside, it wants you to take the old function. So it wants you to take this old function that they have, and then multiply the whole thing by 2. So we have f of x equals 1/2 x, so that's what we're starting off with, minus 1. Then we have g of x, which is 2 times f of x. So we're taking 2 times f of x. Okay, so that says we're going to do 2 times whatever that function was. So that original function was 1/2 x minus 1. Okay, when you do that, you get 2 times the half, which is 1. So 1x. And then minus 2. 2 times minus 1, which is minus 2. So you end up with x minus 2 is your new function. Remember that when you have the number on the outside, it does also change your y-intercept. So it's going to change both. So when you graph it, it's going to look a little bit different than just the slope changing. It's also going to change spots. So when we look at that answer, we see that it was a vertical stretch, and we see that our new equation is x minus 2. Looking at 5, it says describe the transformations and then write the new equation. So again, we want to do both. We want to describe them, and then we want to write our new transformation. So again, we have 2 transformations that are happening here. We have a vertical stretch of 3. The number's on the outside. It's a number greater than 1, so we know that that's vertical and that it's a stretch. So we have a vertical stretch. Okay, and we also see that it's being shifted down. So shifted down by 2. Down 2 units. So again, we want to follow order of operations. Now, in order of operations, remember PEMDAS says to do parentheses first. We don't have anything in parentheses here. Okay. Then it says to take care of exponents. We don't have any exponents. Then multiplication and division, and then take care of addition and subtraction. So we're actually going to take care of this multiplication of 3 first. So we're going to do each part of this one separately. So we have f of x equals x minus a third. Okay, so everybody following me so far? And then what we're going to do is we're going to take 3 times that. So we're going to start with 3 times f of x. Okay, and what that's going to look like is 3 times x minus a third. Okay, and when you do that, what you're going to end up with is 3x minus 1. Okay, now don't forget that we have this minus 2 kind of off to the side, out in the open here. So we're just going to take minus 2 and we're going to subtract it at the end. So take the minus 2 that was here. Okay, don't forget about this minus 2 that we still have to do. We multiplied the entire function by 3, but then we also need to subtract it by 2. So once we have this part, we're going to subtract by 2, and what we'll end up with is 3x minus 3 is our last function. So it was vertically stretched, and then it was shifted down by 2. So what you have is a vertical stretch and down by 2, and our new equation is going to be g of x is equal to 3x minus 3. Okay, 6 says describe the transformations and identify the new x and y intercepts. So we're going to describe the transformation and then we're going to identify the new x and y intercepts. Now remember that you can find the x and the y intercepts without even graphing it. So kind of keep that in mind as we're going through. We know that this is a reflection because it's a negative. We've added in a negative somewhere. And we know that it has the reflection across the y because it's on the inside. So we have a reflection across the y-axis. So kind of remember that. So we reflected. So we have reflection across y-axis. Okay. Now, we're going to transform it. Now, keep in mind that our original function here was f of x equals 2x minus 1. And how we've changed it is instead of having f of x, now we have f of negative x. So instead of x, we're going to replace everything where there was an x, we're going to replace it with negative x. So we're going to have 2 times negative x minus 1. Okay, well 2 times negative x is negative 2x, and the minus 1 stays at the end. Okay? So how did the y-intercept change? Okay, well the y-intercept is still the same. So we have our new y-intercept is still at 0, negative 1. So our y-intercept did not change. Notice that from both equations, the y-intercept is still the same. So the new y-intercept is going to be 0, negative 1. Okay, so y-intercept is 0, negative 1. Now remember, to find the x-intercept, that's when we make y 0. So let's write our equation, and then let's make y 0 and solve for the x-intercept. Okay, so we have y equals, I'm going to come up to the top over here. So we have y equals negative 2x minus 1. This is our new equation. We want to solve for the x-intercept, okay? So the x-intercept is when y is 0. So we have y, or 0, is equal to negative 2x minus 1. And then we're going to solve for the x-intercept. So we have plus 1, and then that's going to leave us with 1 is equal to negative 2x, and then divide everything by negative 2. And what we'll have is x is equal to negative 1 over 2. So x is equal to negative 1/2. And so our new x-intercept is going to be negative 1/2, 0. So the y-intercept is still 0, negative 1, while our new x-intercept is negative 1/2, 0. Okay, so let's describe the transformations and then identify the new x and y-intercept. So again, we have the same thing. Now, we have a number on the outside. We know that this is a vertical change. Okay, and this would be a vertical compression because it's a fraction. So we have a vertical compression happening in this particular one. So vertical compression. And then we want to get our new equation. So we're going to change the equation so that it fits our function of g of x. And then we're going to find the new x and y-intercept. So our original function on this one was f of x equals 3x minus, or plus 6. So that f of x is equal to 3x plus 6. Okay. Our new equation is 1/3 f of x. Right? So 1/3 of this entire function would look like this. It would be 1/3 11/3. Let's change that. So 1/3 times 3x plus 6. Okay, so our new function is going to end up being y is equal to, or g of x is equal to, 1/3 times 3x is 1. So that's just x, or 1x. And 1/3 times 6 is 2. So your new equation is x plus 2. Well, we can automatically see that our y-intercept in this case is 0, 2, because that's the b. So the y-intercept for this one changed. It went from being 0, 6 to 0, 2. So again, just remember that when you're doing vertical stretches and compressions, it does change the y-intercept because you're multiplying that number to everything, including the y-intercept. Okay, now the x-intercept, remember how we find the x-intercept. So the x-intercept is when y is equal to 0. So we have y equals x plus 2. Remember the y-intercept we're going to make 0. So we have 0 equals x plus 2. And so we're going to subtract to get x up by itself. And we see that x is equal to negative 2. So our new x-intercept is negative 2, 0. So we have a vertical compression, okay, because the number was on the outside and it's a fraction. The y-intercept, when we changed the equation, went from being 2 to 0, 2, and the x-intercept became negative 2, 0. 8. This is write the new equation, and then how did the slope change? So, we don't have to describe the change on this one, but let's go ahead and do that part anyways. We have the numbers on the outside, so we see g of x is equal to negative 2 times f of x. Two things are happening here. We have a number on the outside, okay, and it's a number greater than 1, okay, so we're looking at that number 2. That tells us that we have a vertical stretch. The negative tells us that we have a reflection, and because it's on the outside, we have a reflection over the x-axis. So two things happen. Okay, we have a reflection over the x-axis, and we have a vertical stretch of 2. So here's what we're going to do. We're going to change our equation, and then we're going to describe how the slope changed. So here is our original equation, which was f of x is equal to 1/2 x minus 4. It changed by becoming negative 2 times f of x. So now we have this whole function times negative 2. Okay, so negative 2 times 1/2 is negative 1x, or just negative x. And negative 2 times negative 4 is plus 8. So we see that two things happen. And it's asking for the slope, but we're going to talk about both things. So how did the slope change? The slope went from 1/2 to negative 1. So it got steeper because we know that 1, when we take the absolute value of those two numbers, when we take the absolute value of negative 1, and when we take the absolute value of 1/2, we see how those two numbers change. So the absolute value of negative 1 is 1. And the absolute value of 1/2 is 1/2. And we see that 1 is greater than 1/2. So your line got steeper. The other thing that happened is that your slope became negative. So your slope changed and became a negative slope, and it got steeper. We also see that your y-intercept changed. Your y-intercept went from being negative 4 to positive 8. So it moved up quite a bit. So here we see the slope is negative and it got steeper. So kind of keep that in mind as you're going through. Look at those observations. Okay, on 9 it says write the new equation, and again we want to know how does the slope change. So we see that we have a reflection, okay, and this time we have a reflection across the x-axis. So this is a reflection across the x. When the number's on the inside, remember, or when the thing is happening on the inside, when the negative's on the inside, that's a reflection over the x-axis. So we're going to take our equation that we have, okay, which is this f of x equals 4x minus 1. And we see that it changed by becoming f of negative x. So this one's different than the ones that we're doing before. When it's on the inside, you're only swapping out the x with whatever's on the inside. So we're swapping out the x here, okay, this x with negative x. So we'll have 4 times let me change that. That should be a 1. My bad, guys. Okay, so we have 4 times negative x minus 1. So 4 times negative x, that's negative 4x minus 1. So the y-intercept doesn't change on this particular one, okay? Which is true for reflections across the y-axis. But the slope changed. The slope went from being positive 4 to negative 4. So it went from being a positive slope to a negative slope. Okay? So it's now the opposite slope. Alright. So let's describe the transformation, and then what is the new... Now I already gave you the answer here, but we're going to go over it anyways. What is the new y-intercept? Did we do this one already? We have nothing. Okay. I need to... Now, okay, here we go. Sorry. Describe the transformation, and then what is the new y-intercept? So here's what we're going to do. We're going to... We see that... We're going to describe it. So we see that we have a horizontal shift, and it's moving it to the left 1 because we have plus 1. Remember, plus means that it's going the opposite direction. So it should be moving to the left 1 unit. Okay, now let's take what we have here. So we have f of x. We're going to get our new equation because we want to describe what the new y-intercept is. Okay, and let us evaluate. Okay, so we have f of x is being changed so that it becomes f of x plus 1. So how this is going to change is instead of x, we're going to have x plus 1. So instead of negative 2 times x minus 4, we're going to have negative 2 times x plus 1 minus 4. And then we're going to evaluate it. So negative 2 times x is negative 2x. Negative 2 times minus 1 is negative 2. and then you have the minus 4 kind of hanging out here on the end. And then when you change that, what you're going to have is negative 2x minus 6. And so how did your y-intercept change, or what's the new y-intercept? The new y-intercept on this particular one should be negative 2x, or it should be 0, negative 6. So that new y-intercept should be 0 and negative 6. Okay? Everybody good there? Great. Alright, 11. It says describe the transformation and then what is the new x-intercept. So again, we have a reflection over the x-axis. No, that's a lie. We have a reflection over the y-axis because the negative is on the inside. When the negative is on the inside, it is across the y-axis. When it's on the outside, it's across the x. So we have a reflection over the y-axis. And again, we're just going to look at what we have and how we change it. Okay, so what we're going to do is we're going to plug in. We're going to rewrite. So we have f of x equals 1/4 x plus 6. And now we have it changing to f of negative x equals 1/4. And so again, instead of having x, what we're going to end up having is negative x. So we have 1/4 times negative x plus 6. So we have 1/4 negative 1/4 x plus 6. And again, when you want to solve for the x-intercept, you make the y 0. So in our equation right now, we have y is equal to 1/4 x plus 6. We're going to make the y 0. And we're going to solve for it. So we're going to subtract 6 from both sides. That's going to give us negative 6 is equal to negative 1/4. And I'm sorry if that's a little bit hard, if that's hard to see. We have negative 6 is equal to negative 1/4 x. And then remember that we multiply by the reciprocal when we're doing fractions. So we'll multiply everything by negative 4. That's going to cancel that part out. That's going to go away, that's going to go away, and what we're left with is x is equal to, well, negative 4 times negative 6 is positive 24. So your new x-intercept is going to be 24, 0. Okay, now this one wants us to describe the transformation and then write the new equation. Okay, so we have two transformations happening here. We have a vertical compression by 1/3, and then we have a horizontal shift to the right 4. To write the new equation, again, we're going to follow order of operations. So order of operations says to take care of what's in parentheses first, then do multiplication. So we're going to take care of the f of x minus 4 part first. So what you have right now is, f of x equals x minus 8. So we're going to take care of the f of x minus 4 part first. So remember, f of x minus 4 says to swap out the x with x minus 4. So what we have is x minus 4 minus 8. Okay, so what that gives us is x minus 12. Now, we're not finished because we still have to do the 1/3 of that. So now we have 1/3, okay, times f of x minus 4. So we know that this is f of x minus 4. We need 1/3 of that. Okay? So to take 1/3 of that, what we do is we multiply this entire thing now, okay, by 1/3. That is not a good color. So we take 1/3 and we multiply it to that entire function. So we had x minus 12, but we're not done yet. So what we need to do is we need to do 1/3 times x and 1/3 times 12. What that's going to give us is 1/3 x minus 4. So that would be our new equation. So when you're doing multiple transformations, follow the order of operations, do the part that's in parentheses first, then take care of multiplication at the end. Okay, so we would take f of x minus 8 and shift it to the right 4 first, and then do the vertical compression of 1/3 at the end. describe the new transformation, then write the equation. So here, again, we have two transformations happening. We have a reflection across the y-axis, because you have a negative on the inside, and then you're shifting it down a third. So, again, we're taking our equation, so we have f of x. We're going to do each part separately. So we're going to do the part that's inside the parentheses first. So we have f of x is equal to 2x minus a half. And you have, instead of f of x, we have f of negative x. So we're going to replace the negative x in for x. So instead of f of negative 2 times x, you're going to have 2 times negative x minus a half, which is going to give you negative 2x minus 1/2. And then it says, now once you have that, subtract a third from that entire thing. So we're going to subtract a third. Now, in order to do operations of fractions, remember you have to have a common denominator. Common denominator for this one would be 6. So you have minus 3 over 6 minus 2 over 6. And that's going to give you negative 2x minus 1/6. No, that's a lie. Because we have negative 3 and negative 3 over 6 and negative 2 over 6. You're going to add them to give you negative 5 over 6. So your new equation for this one is going to be negative 2x minus 5 over 6. So you're going to have fractions. Just leave the fractions as they are. Okay, the parent function is transformed to g of x is equal to negative 2x minus 4. And it wants to know which is correct. So remember that our parent function is f of x equals x. So we have f of x equals x. That's our parent function. Remember that that's the parent function for all of them. So we're transforming that parent function. We're multiplying it by negative 2. So we're taking x and we're multiplying it by negative 2. So you're going to end up with negative 2x. And then you're subtracting 4 from it. So you're going to have negative 2x minus 4. So you're looking for the graph that has a y-intercept of negative 4. Well, we know that that's not this first graph. So graph number 1 is out. Okay, we do see that this one has a y-intercept of negative 4. Okay, which means that this graph is out. So really, once you look at the y-intercept for this one, you're done. But go ahead and check the slope. We know that our slope should be negative 2. So our change in y here is negative 4. You're decreasing by 4. And our change in x is increasing by 2. So we have negative 4 over positive 2, which gives us negative 2. So this one has a slope of negative 2 and a y-intercept of negative 4. So really do the transformation first, and then look at the representations, and make sure that the slopes and the y-intercepts match up for both of them. Okay, 15, it says Russo's charges $15 for a large pizza. The delivery charge is $2.50. On Saturday, there is a half off pizza special. Write an equation to represent the transformation. Okay, we want to write the original equation first. The original equation, well, actually, let's see. It says write an equation to represent the transformation. We really don't need the original equation. What we have, if you were going to have one though, you're charging $15 per large pizza, so that would be 15x plus a $2 delivery fee altogether, $2.50. So that would be your regular equation. Now it says write an equation to represent the transformation. So it's saying we're taking half off pizza special. Now, you're not taking half off the delivery charge, you're only taking half off of the pizza. So we need something where it's only affecting the x part, the pizza part. Okay, remember that if you do the number on the outside, this is slope change, because we have 1/2. If we do the number on the outside, okay, remember that it's going to affect everything. It's going to affect both the slope and the y-intercept. So it's going to affect the slope of 15 and the y-intercept of $2.50. And we don't want that to be the case. So we're not going to do a vertical stretch or vertical compression. What you're actually going to do is you're going to look at horizontal stretch and horizontal compression. Because when the number's on the inside of the parentheses, when it's on the inside of the f of x part, then it's only affecting the slope. It's only affecting the x part. So your function here would be f of 1/2 x. So we have g of x in this case would be equal to 1/2 of x. So you want it on the inside, and again, because we only want it to affect the slope, not the y-intercept. Okay, 16, it says, does the table represent a positive or a negative correlation? Okay, what you're going to do here is you're going to type in the information into your calculator. So I'm going to kind of go over those steps. I'm not going to write them down, but I will talk you kind of through it as you're going through. So kind of listen to this part. Okay, remember that when you're going into your calculator, we go into new document. So new document's the first part that you go through. You might want to write this part down. If you're making your note card, I would write down these steps. So the first place that you go is into new document. You don't want to save anything, and you know that part. Okay, and then the first place you go to is list and spreadsheets. So you go to list and spreadsheets. When you're in list and spreadsheets, remember that you go up to A, to where the box with A is highlighted, and only the box with A should be highlighted. No other boxes should be highlighted. And you're going to type in X. Okay, X is going to represent economic growth in this case. And then you're going to exit that box, and you're going to do the same thing for B. So you're going to go up to B, where B is highlighted. You're going to type in Y. Y is going to represent our returns. Then go down into the white spaces, the white boxes in your calculator, and you're going to type in those values of 2.1, 2.5, 4.0, and 3.6 for your X's. And for your Y's, you're going to type in 8, 12, 14, and 10. And then what you're going to do from there, we want to figure out what type of correlation is happening. So from there, you're going to make sure that you're in an empty box, and you're going to press Menu. Then you're going to go down to Statistics, which is number 4. You're going to press Stat Calculations. And then you're going to do Linear Regression MX plus B. So if you're writing down the steps, remember the first place that you go is to New Document. That's number 1. Number 2, you're going into a List and Spreadsheets. Number 3 is in the box with A, and in the box with B, you're going to type in X and Y. 4, go back into the white boxes and type in your data. Type in your data for X, type in your data for Y. Number 5 says to go into press Menu. 6, go into Statistics. 7, Stat Calculations. 8, Linear Regression MX plus B. 9 is in X list, make sure you type in X, and then Y list, make sure you type in Y, and press Enter. And then it's going to pull up the title, the equation, your MB, R squared, R, and residual. You want the R, and an R in this particular case, it says 0.662574. We see that it is a positive correlation, and since it's greater than 5, we can say that it's a strong positive correlation. Now, looking here, it says, does this graph show a weak or a strong correlation? Remember that the closer that your points are to your line of best fit, if I were to draw a line of best fit here, the closer they are to the line of best fit, the stronger the correlation. And so those points are not super close to my line of best fit. So I would say that this is a weak or moderate positive correlation. So a weak or moderate positive correlation. So if you're looking for that on your test, if you're trying to figure out if it's between strong and weak, you would say weak. Here it says estimate the correlation coefficient. So you're just estimating it. Again, as we estimate, we know that it's got to be negative because you have a negative slope. Okay, and here when we're estimating, we're looking at how close they are. Those points are not super close, but they're not super far apart either. So if I were going to estimate, I would say negative 0.6 or negative 0.7. You're just giving an estimated numerical value when you're looking at the graph. It does not have to be exact. So kind of know the difference between strong and weak. Again, I know this says negative 0.45. I would be okay with that, but those points are somewhat close, so I would say negative 0.6 or negative 0.5. Again, when you're doing something like this on your test, it should be a little bit more exact, so it wouldn't necessarily stress out about questions like this. 19 says using the graphing calculator, calculate the correlation coefficient. So I'm going to go through these steps again with you. Number 1 would be to go into new document. Okay, you don't want to save anything. Number 2 would be to go into lists and spreadsheets. Number 3 would be in for A, type in X, and for B, type in Y. So X for year and Y for enrollment. I think I'm on step number 5. Number 5 would be to type in the data. So then type in 1980, 1985, 1990, 1995, 2000, and for X. And then for Y, type in 14, 20, 22, 28, 37. And then step 6 would be to press menu. Step 7 would be go down to statistics. Step 8, stat calculations. 9, linear regression, mx plus b. And then 10 would be an x list, type in x, and y list, type in y, and press enter. And then you want R, and R in this case is 0.978. So again, those steps just one more time. Step number 1, new document. Step number 2, lists and spreadsheets. Step number 3, type in X and Y in boxes that have A and B. Step 4 would be to type in the data. Step 5, press menu. Step 6, statistics. 7, stat calculations. 8, linear regression mx plus b. 9, an x list, type in x, and y list, type in y, and press enter. Okay, using a graphing calculator, write the equation. So you do this the same way that you get your equation. So once you've already done the correlation coefficient, once you're already in that spot, you also have the information for your equation. So you need the m, and the m in this case is 1.08, and you need the b, which is negative 2,125. And once you have those two pieces of information, you can write your equation. So your equation would be y equals negative, or no, not negative, it would be positive 1.08 x minus 2125. Okay, I hope that you found this helpful. Again, I'll be in my room tomorrow morning if you have any questions, or if you just want to come in and study for your test. Feel free to come in, and I will be more than willing to help you out. All right, study, get rest, and then make sure that you come prepared for tomorrow.